Very good morning to everyone. In this lecture, EC 8791 Embedded and Real Time Systems, Department of Electronics and Communication Engineering, 7th semester. In previous classes, we are discussing the designing with platform of embedded systems and what are the quality assurance techniques and what are the level of performance analysis in embedded system. Now, today we are going to discuss the consumer electronic architecture in embedded system. The consumer electronics refer to any device containing an electronic circuit board that is intended for everyday use by individual. Example, the television and cameras and digital cameras, calculators, DVD, audio devices, smartphones, etc. So we need the functional requirements. What are the different type of functional requirements are there? There is a multimedia. The media may be audio, still image or video. These media object are generally stored in the compressed form and must be uncompressed to play. For example of these functional requirements, it is a media compression standard, that is a MP3 Dolby digital DM, and then the audio and JPEG for still image, MPEG and MPEG 4 and H.264 etc. for videos. Now the second one is a data storage and management. And people want to select the multimedia object they save or play. The data storage goes hand in hand with multimedia capture and display. Many devices provide the personal computer compatible file system so that the data can be shared more easily. So these kinds of systems, that is we are selecting the requirements. We are selecting the requirements in different strategies. It is a inbuilt testability devices. We are selecting the storage devices, storage data and management systems. Now next one is a communication. The communication may be relatively simple, such as the universal serial board, and another is an ethernet port or a cellular telephone link. So we need a proper communication between the processor and also user. Now, what is the non-functional requirements? In many devices are battery operated, which means that they must operate under the strict energy budget. Then the battery is a 75 milliwatts. It is support not only the processor but also the display, radio, etc. Now the consumer electronics must also be very inexpensive but provide very high performance. Then it use case of selecting and playing a multimedia object, audio clip or pictures, etc. If selecting an object, make use of both the user interface and the file system. That is, playing also make use of the file system as well as the decoding subsystem and input output subsystem. We can consider, we can see this picture. The user, that is we have to different criteria, that is a power up, select and play. So the selection button we are we are interface between the user interface and also the directory. The play button is decoded with this kind of the user and directory. Now we can move to the use case of synchronizing with a host system. If use case of connecting to a client, the connection may be either over a local connection like a USB or over the interconnect. In some operations may be performed locally on the client device. In most of the work is done by the host system while the connection is poor. So the user it can be connected to the host in two ways, that is a connect and a synchronization. The host must transfer the file system, that is a bit by bit, to the one processor to another peripherals. Now, what are the functional architecture of consumer electronics devices? That is a CED. First of all, we are selecting the input output device, that is a functional devices. We are selecting the functional devices like a communication port and also the input and output port and also the what are the main memory. Then we are using the CPU interfacing with the network topology, and also we are connecting through the input output device in the digital signal processing, which type of signal we have to select. So the CPU can be interpolated with these digital signal processing and also the storage, there is a storage and data management system. So these kind of consumer electronic devices we can enable to these several various number of electronics industry. Now it is a two processor architectures. If more computation is required, more DSP and CPU may be added. The RISC CPU run the operating system, runs the user interface, maintain the file system, etc. Then the DSP, there is a it is a programmable one which perform the signal processing. Then the operating system it run on the CPU must maintain the processor and the file system. It is depending on the complexity of the device. The operating system may not need to create the task dynamically. So these are the compensation of the economic system in electronics industry in these consumer electronic devices. So if all the task, that is testing and fault tolerance and fault identification, if all the tasks can be created using the initialization code, the operating system can be made smaller and simpler. Now what are the flash file system? In many consumer electronic device use flash memory for mass storage. The flash memory is a type of semiconductor memory like a dynamic RAM or static RAM. It provides the permanent storage system. The values of stored in the flash memory cell as electric charge using a specialized capacitor that can store the charge for a year. The file system of a device is typically shared with the personal computer. The standard file system has two layers. Bottom layer handles the physical read and write on the storage device, and the top layer provides the logical view and the file system. So the flash file system imposes an intermediate layer that allows the logical to physical mapping of file to be changed. Now the platform level performance analysis. It is a system level performance. It involves more than the CPU to move data from memory to the CPU to the processor. The data from memory to the CPU, we must read from the memory and transfer over the bus to the caches. So in this lecture, we are discussed the consumer electronic devices in embedded system design. Now upcoming classes we are going to discuss the processes, what are the different type of processor we are using the embedded design, and what are the peripherals we are using the embedded system. Thank you for watching this video.